Okay, thanks, Betsy. So I'll be talking about, as Betsy said, the first study, which is on access to effective teaching for disadvantaged students. Pleased also to have two of my co-authors, Phil Gleason and Jeffrey Max, also here in the room. So first, in terms of the overall research questions, as Betsy mentioned, this is an ongoing study. We're primarily looking at two research questions. First of all, to what extent do disadvantaged students have equal access to effective teaching within school districts? And then the second question is that access to effective teaching related to different patterns of teacher hiring, mobility, and attrition for high and low poverty schools? It is really the first question that is the focus of the first completed study that we'll be talking about today. We are currently working on a follow-up brief that will address the second question on teacher mobility patterns, and then we will be writing a final report out in a couple of years that looks at both of these questions and extends our data for another 2 years. So our sample that we're looking at is really a diverse set of districts. One of the things that makes our study a little different from the prior literature is that the prior literature had mostly focused on a more restricted set of districts. One study looked at 10 very large districts. Another study looked at districts from a couple of southern states. We intentionally, purposefully sampled from districts around the country, and our sample includes 29 districts from 16 states. We have districts from all of the 4 U.S. Census regions and at least 4 districts from each U.S. Census region. Our districts are mostly located in medium-sized to large cities, although there are some districts that are predominantly rural as well. In terms of what these districts look like, they look similar to the 100 largest districts in the country. In terms of size, they range from about 20,000 students to over 100,000 students, and they contain more low-income and minority students than is the case of the typical U.S. district, but looks more sort of like those 100 largest districts in the country on those kind of characteristics. We went to our study districts and we gathered from them data on instructors and students for English language arts and math in grades 4 to 8, collecting test score data, collecting data on student characteristics, like does a student have an IEP, and the links of which teachers are teaching which students. And we did this for the most part, 3 years, from the 2008-2009 school year to the 2010-2011 school year. So then how do we measure access to effective teaching? Well, we use 4 steps. The first step was to use a value-added analysis to measure effective teaching. So what this means is that we were looking to isolate the contribution of a teacher's effect on student achievement apart from what the students themselves bring to the table. So to do this, we looked at students' achievement on an end-of-year test score at the end of the year that they spent with the teacher, and used a statistical model to capture how much of that was due to the teacher they had, as well as to the student's achievement on a baseline test score and other student characteristics. So for example, if a student had an IEP, we statistically accounted for how much that was related to student achievement, in order that we were then measuring really a teacher's contribution to student achievement and not just attributing to teachers being effective teachers because they tended to teach kids that were prone to have high test scores. So in other words, when measuring effective teaching, what we were looking at was how did a teacher do with their kids relative to other teachers who taught a similar mix of students. So from there we had a measure of effective teaching for every teacher. That was step 1. Step 2 then was to link each student to the value added of their teacher. So whether that teacher was somewhere above average, whether that teacher was around average, or whether that teacher was below average, we linked students to that value added estimate. The third step then was to divide the students between disadvantaged students and students who are not disadvantaged. So we used eligibility for a free or reduced price lunch as our measure of student disadvantage. So to be eligible for free or reduced price lunch, you have to come from a household that is no more than 185% of the poverty line. I believe works out to about $44,000 for a family of 4. So we have one set of kids in that group, and the other set of kids not eligible, coming from households with higher levels of income. The fourth step then was to compare the average value added for the kids in the one group to the average value added measuring teacher effectiveness for the kids in the other. So in other words, if we pick up a student from the free lunch group and look at the effectiveness of their teacher, pick up a student from the non-free lunch group, look at the effectiveness of their teacher, compare that difference, that's the difference that we're getting, what we sometimes in the report call the effective teaching gap, measuring access to effective teaching. The way that we are structuring it, if that is positive, that says that the teachers of the non-free lunch students are doing better than the teachers of the free lunch students. If that is 0, that means teachers are about equally effective across both groups. And if it's negative, it means that the non-free lunch kids are actually receiving, or the free lunch kids are actually receiving better teaching than the non-free lunch kids. This is sort of a numerical example. I'm going to skip that because I want to get on to talking about the results. So what we find is looking at our 29 districts across the 3 years of the study and the 5 grades that we include, and averaging that together, that we do see that on average there is inequitable access to effective teaching, that the teachers that kids receive favor the non-disadvantaged group over the disadvantaged group. So here you see the estimates. This is in terms of standard deviations of student achievement. In English language arts, we found that the difference on average was 0.034 standard deviations of student achievement. For math, the average 0.024 standard deviations of student achievement. So this is again, these bars showing, because they're positive, that this is favoring the non-free lunch group. Now, how big are these estimates, 0.034, 0.024? One way to gauge it is to look at how this would change the student achievement gap. So what you see here is, on average for our districts, what is just the gap in student achievement between free and reduced price lunch eligible students and students not eligible. What you see here for English language arts is that the average student not free lunch eligible is at the 68th percentile of achievement among students, and the average free lunch eligible student is at the 40th percentile. And there are similar differences for math. Now, if we were to have had equal access to effective teaching instead of the unequal access, how would these change? They would change by 2 percentile points. So now what we would have seen is that in English language arts, at the end of 1 year, the non-free lunch students would be at the 67th percentile, free lunch students at the 41st percentile. So again, here's the actual percentiles. Here's what we would have had with equal access to effective teaching. So just a slight change corresponding to the 0.034 and the 0.024 that you saw before. Another thing we did was to look across our districts. So this is 29 bars, each one representing one of our study districts. Each bar here is a district, and what you're seeing is this measure of access to effective teaching. Here's the average, the 0.034 that you saw before for English language arts. And when you see the solid bars, these are the districts where you had differences that were statistically significantly different from 0. So here's where we have evidence for less effective teaching. The 2 districts that we put over on the left, these we say are approximately equal because they're not at least statistically different from 0. So in addition to seeing that most of the districts have statistical differences, you also see a range among those districts. Well, there is a pretty decent sized group somewhere around this average of 0.034. You do have 3 districts up here that where the difference is greater than 0.06 in terms of, again, standard deviations of student achievement. For math, story a little bit more equitable. Again, the average difference is lower. 19 of the districts, we have evidence for less effective teaching based on statistical significance. 10 districts, approximately equal. Difference is not statistically different from 0. But again, 3 districts up here with differences that are much more inequitable even than the average. Final thing that we did was to look at how these differences break out as far as being differences attributable to between school differences versus within school differences. What I mean by that is how much of these gaps that we measure are due to the placement of teachers and students across schools. And this could be responsive to a number of policies, including the way that teachers are brought into the district, the way that rules for which teachers can transfer between schools, that could be affecting these between school differences. The other thing that we looked at are within school differences based on the way that principals assign teachers to students within schools. This could, say, result from a tracking policy, say within a middle school. So we break it out. The result here is that this is, again, the 0.034 and the 0.024 you saw before. What we have here is the between school part versus the within school part. So as you can see from the figures, most of the difference actually is between school rather than within school, although the within school also adds a statistically significant amount to the total total amount of this gap. And the between school part is especially important for English language arts. So again, just to review, we do document that disadvantaged students do receive less effective teaching on average. We see that equal access in 1 year would reduce the student achievement gap by 2 percentile points in English language arts and in math. We see that access to effective teaching varied across the districts that were in our study. And we see that the differences are more related to the way that teachers and students are placed across schools than to the way that principals match teachers and students within schools. And with that, I'll turn it over to Steve to talk about the next study.